Hi, I'm Jeppe and I'm a physicist working here at Nanonode, and today I'll be demonstrating how to set up a job and prepare a sample and do a measurement on this Tveskaeg G3 Flow system here. So we'll get started by going into the machine and setting up the job. So if we go into the main menu here, or the main interface here, we press New Job, and then we'll give the job a name, and you can do all this on the touch interface on the machine. So we'll just call this demonstration. Press OK. And then we have this option here to use sample tagging. So when you enable this, it will ask you for a tag before you do a measurement, which will allow you to associate the measurement at a later date with your sample if you want that. So for demonstration purposes, we'll enable that here. And then you can set the mode to be either continuous or manual. In manual mode, it will do a single measurement according to the job when you press run. And if you have it in continuous mode, then it will keep doing measurements continuously until you stop it and report the results as it goes. If we go into this menu here with parameters, we can start setting up our job. So this machine here has 5 profiles on it. So what we will do is, I suggest we maybe measure sodium. And what you can see here is it has an estimate for what the expected standard deviation will be in parts per million or milligrams per liter for the given measurement time. So right now it's expecting to have a standard deviation of 8 milligrams per liter on a 1-minute measurement. But we can actually adjust this. So if we increase the measurement time, we get a more precise result. So let's just say we want to measure 2 minutes on sodium. And let's say that we want chloride as well. And we'll measure for 2 minutes on chloride as well. And then we'll measure on lithium for 10 seconds. So this lithium option doesn't have the opportunity to increase the sensitivity. And that's an implementation detail because this is a very short measurement. And then the rest of the panes in the menu here, we don't really need to concern ourselves with. So we'll just press Save Job and then put in the pin. And the pin for your system will be 1, 2, 3, 4, and then you press OK. So now the system is ready to be run. And we'll be setting up a sample. So I'll demonstrate how to use the sample tubes and how to aspirate the sample and insert it into the machine and run a measurement on it. So here we have a little vial with a sample labeled CO26. So we'll be putting in some of the sample into the sample tube. So I'll just unscrew the lid here. And then here we have the sample tube, and you get 10 of these with your system, and you can purchase additional ones, and they are reusable. So the way to use them is you would unscrew this end cap here just with your fingers, and then the accompanying aluminium rod you would insert in the tube here, screw in, and then you're ready to go. So now you would insert this into the container and then just draw up a sample. And you want at least 6 centimeters or 7 centimeters of this, ideally, which is about 3 inches in imperial units to be aspirated. It doesn't matter if you aspirate too much, but don't go below these 6 or 7 centimeters. I think 7 centimeters is nice because then you have a bit of wiggle room. And then you just screw the cap back on, and then you can wipe away any excess, and then unscrew your aluminium rod, and then your sample is ready to be measured. And you just insert it into the side of the machine here, and you push until it hits the end stop, and then you're ready. So what you'll do next is go over to your machine, and then you simply press run on the job that you want to run. So we'll be running this demonstration job here, and I'll just press run. And because we enabled sample tagging earlier, we'll be given the opportunity to put in a sample, and I'll just put in the label on this vial here so I can match them up later on. And that was CO26 or C026, I guess. And then the system will start measuring. You can hear some faint relays clicking inside, and that means it's measuring. So now it will measure on hydrogen first of all, and then based on the result of that, it will adjust its measurement frequency for these different isotopes accordingly. And the measurement is sequential, so it will start out by measuring 2 minutes on sodium for a very precise result on sodium. They'll measure for 2 minutes on chloride. Chloride is less sensitive, but we should still get decent precision with this. And then at the end, it will measure for 10 seconds on lithium, which will also give a very precise result because lithium is very sensitive to NMR. And I'll just leave this running, and then we can have a look at the result when it's done. So it's coming up to the end of the measurement now, and it just finished lithium. And we can see we have our values here for what it's measured. So it's measured about a little less than 8 grams per liter of sodium, and a little less than 10 grams per liter of chloride, and 1.5 grams per liter of lithium, or 1480 milligrams per liter. And that's exactly where we would expect the measurement values to be for this sample here. So this sample here is actually a synthetic lithium brine, not quite as concentrated in sodium and chloride as what you might find directly from a natural brine, but it is intended to mimic what we would find there. And we use this internally for calibration, but this is right around what we would expect. Thank you so much for your attention. I hope it was helpful. And if you have any questions, please feel free to contact us, and we'll be happy to help you get the most out of your system. Thank you.